And one of the things that makes this tunnel unique is the design of the flow circuit. We designed it in a manner that allows it to be very compact, take up less space when compared to conventional wind tunnel and water tunnel design. The tunnel itself has a free surface. It's two-dimensional in its geometry, and everything starts on this end where we have an axial flow pump. It's about 2,000 gallons a minute capacity. It's running now. It's very quiet. It's controlled by a variable frequency drive and a 10 horsepower motor. The water exits the pump vertically and goes into this section of the tunnel, which we call the delivery section. And the shape of the delivery section was developed by utilizing Laplace's equation, which in this case, if you solve for the flow of a uniform stream crossing a point source, you end up with the internal shape of the delivery section of our tunnel. The flow comes up, it exhausts out a vertical pipe in 360 degrees of direction. The delivery section turns the flow this direction, and this is a flow conditioning section which has honeycomb flow straighteners and screens and perforated plates which provide uniformity of the flow. The flow then exits the conditioning section and goes into the contraction section, which is a conventional contraction, 6-to-1 ratio. Very carefully designed in terms of its internal contours to minimize flow separation and vortices in corners. Flow then comes out of the contraction section into the test section. The top speed here for our normal tunnel is from 0 to 1 foot per second. We found that for flow visualization purposes, speed in that range is perfect, and as well is perfect for data acquisition. The flow then goes into the diffuser section, and rather than having a normal, very large diffuser and return section, we simply stagnate the flow on an end plate. Mother Nature has no problem with that. The flow then splits and goes into two downcomers where vortices form, and then are ganged together and return to the pump. But the beauty of this compact configuration here is this window is very close to the test section. We should take a shot through here, Jeff. And you can see the model quite clearly. And many times what we do is we'll put a laser light sheet across the test section, which will allow us to view what we call the cross-flow plane and understand these complex flow patterns that form at high angle of attack. If we were in a normal, quote-unquote, flow circuit design, the only way we could do that would be by putting mirrors into the test section, and those mirrors then have a typical negative effect on the flow quality.